Okay, so this is the 5th year maths exam, summer 2025. Question 1 is a complex numbers question, and in this question, as always, you're told the fundamental concept of complex numbers: I squared is always equal to minus 1. Then you're told that one of the complex numbers, z1, is equal to minus 4 plus 2i, and z2 is equal to 2 minus I, and you're asked to plot these. So I'll show you the biggest mistakes first of all that students make. Minus 4 plus 2i, a complex number always takes the form of the real plus the imaginary, or kind of the a plus bi form there. But minus 4 plus 2i, so out to minus 4, up to 2i, and they plot the dot, and then they go out to 2 minus I, out to 2, down to minus 1i, 2 minus 1i, and they leave it like that. Already you're losing marks because you have not labelled your points. So that should be z1 and that should be z2. The next part then is write down the value of z1 with the line above it, and it tells you afterwards that z1 with kind of line above it is the complex conjugate of z1. So I'll give you the answer here, and then I'll tell you what the complex conjugate means. So the answer to this, so z1 is minus 4 plus 2i. That's what it is. So if I put this little line above it here, the complex conjugate of it, all we do is we change the sign of the imaginary part. So the imaginary part was a plus 2i, that now becomes minus 2i. So our answer there is minus 4 minus 2i. So all you've got to remember is change the sign of the imaginary part. Now a little note about that in the background here. The complex conjugate, if you're ever asked it in the exam, it's the reflection of a complex number in the real axis. So it's the reflection of it, and I've demonstrated it here. Z1, and I've just given a random example. Z1 here is 2 plus 3i. So Z1 is 2 plus 3i, and if I reflect that in the real axis, so do a reflection of it down to here and reflect it there, the far side, we'll end up with 2 minus 3i. And as you can clearly see, you change the sign of the imaginary part only. So that's the complex conjugate there. So again, changing the sign of the imaginary part, it's minus 4 minus 2i. Next part, work out the modulus of z1. So a little note on the modulus. The modulus means the distance of a complex number from the origin, how far it is from the origin. And this is the formula. It's based on Pythagoras' theorem. That's actually what you're doing. You're using Pythagoras' theorem. Square root of a squared plus b squared, or as I like to call it, square root of the real part to be squared plus the imaginary part to be squared. So with that in mind, z1 is minus 4 plus 2i. Just let's get clear here that that's the real part is minus 4, and the imaginary part is 2. And so the modulus now, or you can an actual proper name there, z1 is what we're finding, the length or the distance of that complex number to the origin, square root of the real part to be squared plus the imaginary part to be squared. So I'll set it up just to show you. Brackets there for the real part, brackets for the imaginary part, and that will always be a plus in the middle, will never change. So when I now go to fill in, the real part is minus 4, the imaginary part is 2, and we end up getting, so if you do this in your head, you'll get square root of 20. You do it on your calculator, you get 2 root 5, and that's what it's asking you for in the form a root b. Moving on to the final part of this question, part B, and it's an equality of complex numbers question. So in this question you're told that u minus 2v is equal to minus 3 plus 10i. So u minus 2v, that's u minus 2v is equal to minus 3 plus 10i. So a little note about equality here first of all before we do the question. This is all about equating the real and the imaginary parts on both sides. Gives us two separate equations to solve. So basically when we get down near the end here, on the left hand side you have the real part, will equate to on the right hand side the real part, and similarly with the left hand side, whatever the imaginary part is will equate with the imaginary part on the right hand side. So we need to tidy it up first of all, put in what u is, put in what v is, and we'll get minus 3 plus 10i. So u there is and we're told it's 1 plus 4i in the question. We're told that v is a plus bi. So I will then remove, so you get marks for doing that. Actually substituting in, you will get marks for doing that. Then what we do is we remove the brackets. Remember, if there's no number out the front, it's just a 1. So, and you multiply 1 by anything, you get back what you multiply by. So 1 by 1 is 1, 1 by 4i is 4i. Be careful here, minus 2 by a is minus 2a, and minus 2 by bi, so minus by plus is minus, 2 by bi is 2bi, is equal to, and it's just minus 3 plus 10i on the right hand side. So what I'm going to do next of all now is I'm going to take away 1 from the left hand side. Right, there's no more numbers here, there's just the number 1. I'm going to take away 1 from the left hand side, and I'm going to take away 1 from the right hand side. So take away 1 from the left hand side, it's going to disappear. Take away 1 from the right hand side, we're going to get minus 4. Then I have a 4i here on the left. I'm going to take away 4i from the left hand side. I'm going to take away 4i from the right hand side, and that's going to leave me with 6i. And then finally I'm going to just leave the minus 2a and the minus 2bi there on the left hand side. So again, all I did here in this was I took away 1 from the left, I took away 1 from the right, and minus 3 minus 1 is minus 4. I took away 4i from the left hand side, and I took away 4i from the right hand side. I can't do anything with these because these are not like any i's or any numbers, so I just left them there. Now it's time to nearly start equating if you want. So starting equating, if you notice here, that's the real part here on the left, there's no i's in it. That's the real part on the right. So let's deal with that first of all. So equating the reals, we get minus 2a is equal to minus 4, and that's called equating the real parts. So equating the real parts, and finishing that off, divide by minus 2, you get a, divide by minus 2, and you get 2, and that's the answer to that first bit. Done. You get just a there. So that was equating the reals. And now equating the imaginaries. So the imaginaries here. Now this is where you leave out the I part. So when I go to equate the reals, I could go minus 2bi is equal to 6i. But if I divide I on both sides, I will then be left with minus 2b is equal to 6. Right, so think about it, minus 2bi is equal to 6i. I just divide I on both sides anyway. So you can just leave out the I there. Minus 2b is equal to 6. Minus 2b is equal to 6. Now if you want, put it in, if you're unsure, put in the I. Minus 2bi is equal to 6i. That's equating the imaginaries. See, there's an I in both parts. An I here and an I here. And then I divide by I now, and we get left with minus 2b is equal to 6. And the last part to do here is divide by minus 2, and you get b, and divide by minus 2, you get minus 3. And I think that's the answer to that question. Yes, it is. So that's the answer to that one. Question 1 done. How do I stop this fella?